Hi folks, it's Mr. M here with another video. This time we're looking at lesson number 11, which is more factoring. We're not looking at necessarily any new theory per se or concepts. We're just applying the concepts from last lesson, factoring part 1, in a mixed format. So mix and match the questions just to see and practice in different scenarios, right? So let's just go through these questions together. All right, so factor fully. I've written it out here, but when it's two terms, always ask yourself common factor. So I factored out common factored out at 2m. My GCF is 2m. And then I have a difference of squares here. So I'll write that as a minus b, a plus b. Okay, that one's good. Here, common factor is 2. So I've factored that out. I have a simple trinomial. And I'm going to just use man. The two numbers are -9 and -1. So I'll write that like this. And these are each individually a difference of squares. So I can factor these out individually as well. So there's more steps, right? So then x minus 3, x plus 3, x minus 1, x plus 1, respectively for this and this. Okay? And don't forget to put the 2 in the front. Okay, good. So moving on. Here I have a trinomial. I'm going to test and see if this is a perfect square, because I could do complex trinomial factoring, like using the man with a twist. That would probably work. Let me actually try that over here. So just like, let's say you thought that this was a, man with a twist or decomposition. My two numbers would multiply to 16, add to -8. My two numbers that would allow that would be, let's see, 4, 8, and 2. No, it wouldn't add to 8. What are the factors? So I'd have 4. Sorry. Okay. Sorry. I have 8 times 2. That would not add to -8. I have 4 and 4. Oh, there we go. Okay. I don't know why that took a bit of time. But my two numbers are 4 and 4. So -4 and -4. And so those two multiply to give 16, and they add to -8. So those are my two numbers. And with man with a twist, I'm just going to divide each one by a, so 16. So divide this by 16, divide this by 16. Here I'm going to get, and notice they're the same, right? I'm going to get -1/4, and the next one is -1/4. So now I can write my two answers as man with a twist, right? So then it's going to look something like this. This is going to be the top, the end rather, so -1. This is also going to be at the end, -1. And then I don't have any y's or anything here, so I just leave it as a -1. And here I have 4x squared, 4x. So that's the coefficient of x, 4x and 4x. Notice that these two are the exact same, so this is a perfect square. So I get 4x minus 1 squared. So I could do this using man, but really that took a little bit of time. I could have just done test to see if it's a perfect square in the beginning. This is square rootable, this is square rootable. So a and b, now you just want to double them. Sorry, you want to multiply them times the product and double it and see, do I get an 8x? And so 4 times 1 is 4, doubled is 8. So it is in fact what I have here. So this is a perfect square. It's a minus here, so I'm going to put, checking the -2ab and then minus, and so I can write a minus b right here and then square it. Okay, so that works. Here, I'm going to common factor first, and then I kind of want to rearrange it too, generally, and because it's like constant x squared, I want to write always the x squared first and then the x and then the constant, right? Just makes it easier to see. And once I do that, I'm going to complex trinomial factor here with man with a twist. That's what I prefer to use. You can use decomposition too. Multiply to 40, add to -14. Numbers are -4 and -10. And I'm dividing each one by 5. And so I get these two factors right here. These two, so -10 and -2, divide, on top, and then 5 on the bottom, 1 on the bottom here after these two are my factors, -4/5 and -2/1 after I've divided, reduced. And so I can write out the factors like that. 1x minus 2, 5x minus 4. Okay, and with the 2 in front. This kind of thing right here, the common factor is an x. So I factored out an x and I get this. This is a difference of squares, x minus y, x plus y. Nice and easy. Here, the common factor is a 3, and this is a simple trinomial. This is a trinomial. But what you're going to realize, folks, when you try to do this is some questions are just not factorable, right? If you try to do this, I can't find two numbers that multiply to 12 and add to negative 12. None of the factors allow for that. So none of the factors of 12 allow for that. So it's not applicable. I would literally just write this as this is a final answer. It's not factorable. That's it. That's all. You just common factor it, and that's it. Okay, moving on. Here I get something like this. Generally, when you have 4 or more terms, you want to think, like if you can't common factor, you'll want to think of factoring by grouping. So one thing I'd like to do is to put this in order just to make my life easier. I'll put it in order with the x squared next to the x cubed and so on. So x squared, x cubed, x squared part x, and then the number. And then the first two, I'll put a bracket around it, and the last two, I'll put a bracket around it, right? Here, I'm going to factor out from here, common factor is 2x squared, and then I get an x minus 1. The common factor here is just positive 5, and then x minus 2. Same thing here, x minus 2. And so the common factor now you could see is an x minus 2. And I pull that out from each one, and I get 2x squared plus 5. Okay? Here, it's very similar. Put in order and group. So I put this in order, in descending order of degree or power, the exponent. And so I common factor out a negative z squared here, and just the number negative 5 here, and I get z minus 2 and z minus 2. I can common factor a z minus 2. So I write z minus 2, and then I'm left with this right here. Now, there is more than one way to present this final answer. That's very true, because I could have equivalently written this. I could say that this is also equal to, well, z minus 2 stays like that. I could have factored out a negative 1 from the latter, and I would have gotten something like this. Something like this. I would have gotten a 2z, I would have gotten a 2z squared plus 5, because if I, redistribute that negative 1, I would end up with this again. But if I did that, then my answer would look like something like this. Negative z minus 2, 2z squared, 2z squared plus 5. This is also a valid answer. Some of you might distribute this into the negative, and you might get like, negative z minus 2, or sorry, plus 2, and then 2z squared plus 5. And, you could rearrange this, put the constant in front, and so you could get 2 plus z, 2 minus z rather, 2z squared plus 5. So that's also a valid answer, because all I did from here to here was I just took the 2, put that in front, and put the negative z at the end. That works as well. So these are all valid answers. Generally, we want to have the z in front, though, so that this answer would probably be the best out of all of them. But this works too. So there's more than one way to present the answer. As long as the logic makes sense, that's what matters. Okay. Just a few more here. We're looking at here. It looks complicated, but it's actually just a difference of squares, because it's like this is one term and this is one term. My whole a is this, so a squared is this, so my a would just be square root of 49, 7, and then 2x minus 3. So as I've shown here, my b would be x minus 5, square root of this. And then I write a minus b, a plus b. So I have this thing minus this thing right here. I like to put brackets because it's subtraction. And then I have this thing plus that thing, b. Okay, and I simplify this, meaning I like simplify the insides. I multiply that 7 into the group right here. And so I get this and this for the second bracket. And then I just collect like terms, and I get this and times this. Okay, so that's as factored as it gets. Okay, here, this is also a difference of squares. Don't worry that it's like a fraction. I can take the square root of this, and I can take the square root of this. So a would be x cubed over 4, b would be y5 over 5, and then I could write this as a minus b, a plus b. That's it. That's all. Last question here is I get something like this. Now, this is very tempting to think that this is like factor by grouping. You don't want to go down. Actually, I'm curious whether, yeah, no, I don't think you should. Yeah, I don't think factoring by grouping is going to help you here, because like you could try it and you'd realize quick that, okay, well, there's a common factor there. There is no common factor for 25 minus 16y squared, unfortunately. So you're going to notice quickly that factoring by grouping is not going to get you anywhere. In this case, it's like you kind of have to train your eyes to see things differently, and you have to realize that these first three is actually a perfect square, because this is square rootable, this is square rootable, and like if you take the square root of 4x, sorry, if you take a, which is 4x, and you take b, which is 5, and you multiply 4x by 5, you will get a 20x. And it just means that it's going to be an a, it's just going to be like an a minus b, okay? So this is a perfect square. This does check out right here. So negative 2a times b is actually my middle term right here. So then I could write, well, a is this. So sorry, a squared is this. So a is going to be 2x right here. And then b is going to be 5 because b squared is 25. So I write a minus b, and then it's a perfect square, y minus, because here it's a minus. And then I'm going to square that like this. So a minus b squared, all squared. And then I have, don't forget the negative 16y squared right here. So I write that. And this is a difference of squares. So I'm going to write a minus b. Remember, now a is the square root of this, and b is the square root of this. And then a plus b, remembering to put the brackets, because when as we saw here, when you're distributing that negative, you got to be careful. It's going to be negative x plus 5 is what we got here, okay? So just be careful. Here it's okay because it's only one term that you're subtracting or adding, so brackets wouldn't be, like if you didn't include it, it wouldn't be the end of the world, but just better to be safe than sorry. And when I simplify this, I can't collect any other like terms, so this would be my final answer, and that would be it. Okay, so here's your homework for this lesson. It's factoring all types of, it's a handout number 2 on factoring. So it looks like this. Here's some practice problems. There's a bunch of them, but again, they're mixed in mixed order, which is good for you to kind of train your eyes and see what the different factors are. I believe there is a mistake with this question, not with the question, but with the answer to that question. The answer should be, so if I, for number 11, actually, let me look here. Number 11, x squared plus 8xy plus 12y squared. So, oh no, that one's okay. Sorry, it's number 10 I'm looking at right here. Number 10. The answer to the, not number 11, number 10. Number 10, x4 minus 5x squared minus 14. The answer to this, when I factor, it's a simple trinomial. So it's going to be x squared and an x squared. And the two numbers that multiply to negative 14 and add to 5 are going to be negative 7 and 2. So I'm going to do negative 7 plus 2. That should be my answer, not what is written here, okay? Sorry, so this should be an x2, and this should be an x2. Okay, so just please, just be conscious of that one right there, okay? That was a mistake with the question. So I'll just correct that here. Okay, so this is going to be a 2. This is going to be a 2. All right, the exponents, okay? Everything else looks okay. All right, now those are the questions. These are the answers. There is another handout here, so I'll save this. Sorry, it's okay. I don't want to do that now. But these are the answers to those questions up above. So there's plenty, right? And then I look at, I have another worksheet right here. You could try this out as well. But the main, like you should really definitely try the first one is very good. Okay. All right. Thank you, folks. Have a great day, and I'll see you in the next video.